Hello everyone, welcome to the fifth episode of the series writing a in-memory database in C programming language. We're trying to write a key value in-memory database completely in CLang, and so far we've implemented the basic functionalities. And if you're interested, like how does it look like, I can probably also show you the basics. But the whole idea is that there's an interactive shell where you can just say add name emod, for example, and now if you ask for the value of name, you're going to get back the emod. And how it works behind the scenes, you have to watch the 4 previous videos for the implementation. But in this one, I'm trying to on the fourth one, I thought that's going to be the last episode because we implemented the basic functionalities, the things that I was trying to learn from this series, this let's say milestone was already achieved, I would say. But then I was like, okay, let me learn more stuff while still staying on the same project. And now I'm trying to learn writing tests in C programming language and also multi-threading. So the threads are really important in C. I would go for them and learn it. And also, I want to change our approach, our design, into something like core client approach, where we can have just one database engine which exposes the functionalities over TCP, and clients in a concurrent way, they can connect to the same core or the engine and like perform actions, and then the concurrency should be handled. The race conditions should be like a challenge that should be fixed in the code. And those are pretty much the most interesting things that I really want to tackle while learning C programming language. So that's why I'm still continuing this. If you're interested, just watch it, how I do it. It's not a tutorial video. It's like how I learn stuff about something, and just the workflow I usually go through when I want to implement. So it's not a tutorial. I'm not a C programmer. I'm not a professional at it. I would go and start with writing or updating our README, let's say. And the first to do that I've added to our README is that I want to refactor the code in this session in terms of like following DRY. We shouldn't really repeat ourselves, like having duplicate sections of our code. And then I want to implement some clean code stuff. I'm not really sure on what level I have to do that, like how much I'm going to be successful at that one, because clean code is really, in my opinion, of course there are some standards, but at some point it also involves personal taste, and it really depends how I look at the code, and a different person can say, no, that's not a clean code, of course. So I would just follow DRY for now, probably, and keep the clean code for later, but I'll do my best to keep the code clean still. And probably I'll try to write tests, unit tests for the basic functionalities that we have already implemented. And there, I have to say that I've never written any like tests in C programming language before, so it's going to be a completely new journey for me to understand how the built-in functionalities probably, or the framework that we're going to use, is being used, or like how does it work behind the scenes. As the third one, as I told you and already explained, I'm going to convert the database code in a way that we have a core and client approach, where the clients can connect to the core and actually perform operations on TCP. And even the most interesting part, concurrency, that should be handled with threads and mutex and blah blah. So let's just start with the refactoring the code. I'm probably writing the unit test, but it completely depends how long the refactoring is going to take. If that's going to be really a small amount of time, then I'm going to also tackle the writing tests. But if not, then I'll keep it as a separate episode for later. By the way, if you want to access the repository's code, like the source code, you can have the repository on GitHub's link in the description of this video. that's it. Let's just start quickly. So the parts that I want to, oh, by the way, let's create a new branch first of all, and I'm gonna go with feature emod refactor first version, I would say. Yeah. And what do we have here? Okay, make f clean should clean those. Make f clean. I'm not sure why the O file is still in the git tracked files. I have to fix that later as well, but that's not true. We shouldn't really push any executable files or like output like object files. Are they called object files? I think so. To the repository. You should avoid that. And if you want to provide executable files like compiled version, you have to do it with CI pipelines, not like building it on your personal machine and then pushing there, of course. So I'll just discard that change. I'm not sure why the git ignore doesn't work in that section, but I'm gonna just take care of it later. For refactoring, I really want to start with checking the hashtable.c file. And as far as I remember, first of all, let me just remove this command, because I would say for now we're going to just tackle some other challenges for learning purposes. I'm not really interested in handling the multiple types as value in this database, because that's a very obvious kind of thing to solve, but also it has some dirty kind of solutions that I'm not really interested in. Probably we're gonna, this episode, this series is gonna be a long one in my opinion, so I'll just keep it in the to-do list as well. I deleted it from here because it's not my priority for now, but later I probably will tackle it as well. So the part that I was thinking about before starting the recording was this section, where we try to somehow go over all of the entries of the hash table and set the state to empty and also the key and values to null. So it's something like resetting the hash table, right? And the same thing is happening in extend table. So when we want to extend our hash table, we after like extending it, we try to go over all of the entries and make them empty and null as initial values, and then we try to copy the old ones to the new hash table. But there we still have the same code, right? And I was thinking maybe we can just create a function, a generic one, and call that instead of writing that code there. Because if later on, of course, I'm not here to explain why dry is a good principle, why we shouldn't have duplicate code, but just as a reminder, it's going to be really, really, really easy in terms of consistency of code. Like later, if you want to change how you reset your table, you just change in one place, and it's going to have impact on all of your source code. So you shouldn't really change in multiple places. That's only one reason of one good advantages of using dry or following it. So static void, I would say. Yeah, because I'm not sure if I want to really return anything as a result, like an integer, if it was successful or not, because I really don't know if something happens when changing the state of a variable in memory. I don't think I can catch it there. Probably I can catch it there, but I don't really want to tackle that challenge right now. So I'll go with reset hash table, maybe. Reset hash table entries, I would say. Yeah. And as I explained, I'm going to just copy this and paste it here. It's that easy. I'm not going to do anything special. Instead of using this here, I can now simply say reset hash table entries. That should do the job. Also in the second section, which is here, I can remove this and run like that. Cool. And in insertion, I don't think we have the same functionality anyways. How about searching? I don't think so. But I can think of... Okay, let me go through insert and search and see what is actually duplicated there. So in insert, I go check the get load factor. If it is greater than 0.7, I extend the table. If the table is not extended or there's an error, I just throw the error, or I just log it, not throw it, because we're not panicking here. We're just printing to the std out. And then the thing I'm doing is like hashing h1, h2, double hashing, I mean. Then I'm going through creating the index and the step variable, and then I do a for loop and use those index and step. I think that's the same logic that we have here as well, right? I can just make that yeah, I'm gonna do that. I will go and to the top of the file and call a function as static I know what to do. I'm gonna create a struct actually for that. Type def struct, and there I'm gonna be like, what should be the name first of all? It should be prob index. Let me see the code again to see what am I doing here. The thing that I need is I need index and step. So yeah, double hash result maybe, an integer index and integer step. Yeah, I think that works. And here static hash, or I'm gonna go with double hash, and I'll get the key probably. So const, yeah, character key, only the key is needed. And then I'm gonna copy and paste that section to like that one. I'll take that and I will put it somewhere. Where is it? Where's the function I created? Oh, here. And I put it here. And once I do that, I can create the allocation. I can create a struct, right? I'll go with let me think. Hash table result. Hash table result is, can I do it like this? Index and step. Is it allowed NC to do it like this? I'm not really sure. And return HDR. I don't think so. But what am I returning is hash table result. I think it works. By the way, should I return a pointer to that? I think it's better to return a pointer to that. Oh, sorry. I think it's better to return a pointer. No, it's not that easy. I have to... How should I return a pointer to that? Okay, this is a good learning topic for me to understand pointers better in terms of performance. Let's go and ask ChatGPT about this. This is an important one. I have this function, and I wonder if returning a pointer to htr has advantages rather than returning the am I returning the values? Correct me if I'm not returning value here either. You're returning a value, not a pointer, exactly, and this is actually the correct and better way for small structs in C. Here's why. Are you returning a value? Yes, this is a value of htr. This returns the struct itself by value, equivalent to returning 2 integers in one package. That's true. Would returning a pointer be better? Usually no, and here is why. You cannot safely return a pointer to a local variable. If we were in Rust, I would say the compiler could just throw a warning or probably an error that you cannot really compile your code. If you are declaring a local kind of variable and then giving it back to a top level kind of runtime environment, which is calling this double hash, that can cause some problems in terms of accessing null references, I would say. htr lives on the stack and disappears after the function returns. Dangling pointer is gonna happen exactly. Undefined behavior. You'd have to allocate it, but that means caller must free it. Annoying, exactly. More heap allocation, which is slower. But here, because we're just dealing with some primitive data types, like integers. It's like a package of 2 integers, right? It's gonna be for sure in the stack, and it will increase the risk of memory leakages. So I was thinking about returning back a pointer, but in this case, I think it is much better to just return a value instead of a pointer. So when is returning a pointer useful? Only when this struct is very large, not your case exactly. You need to mutate this struct inside the caller. Not your case, you're only returning values. You intentionally allocate something persistent, not needed here. Yeah, we really don't want to persist it on heap and access it from somewhere else, right? No, because when I'm calling this function in insert, I don't want the result to be persistent and be read by the search, which in the same search function I'm going to use the same functionality. So yeah, exactly. Conclusion. But let me see how it would look like. Like if you want maximum clarity and no copies, you could also pass an out param. Okay, so you just, I don't like it either. You, as the second argument, you send in a pointer and then the function tries to mutate the index since that were the properties of that pointer struct, but I won't go with that. How let me go with this one. So that was the error probably that I was seeing. So if I make it like this, and then here I try to return with @, which is the address of the that variable. Now if I go check the warning, telescope diagnostics, it's like address of stack memory. Why I don't see the rest? Address of stack memory. Probably it's complaining about the dangling pointer, yeah, because if it is in the stack, when the lifetime of that variable ends, probably the end of the function, that is going to be deleted automatically, right? So let me just also ask this one. So in my function, not using pointer returned, not using pointer, would htr allocated memory on a stack deleted after lifetime of double hash func ends. This is not a good time for A/B testing. I'll go with this one. So it says yes, but that's exactly why returning it by value is safe. Okay. Exactly. So I'll go with just a value here. And once I do that, I can now use that in insert and just ignore all of these, right? I would say, yeah. And now I can simply say hash table result htr equals, what was the name? Double hash. And there I have the key. Once I have that, I can simply say htr step. No. I can say htr step. And index should be also htr index. And where else I'm using something like that? I don't think I'm using it anywhere else. Just in search, I have to do the same. Delete, delete, delete. And htr, sorry, hash table result. Why I don't have it? What happened to my code? Okay, hash table result htr equals double hash, key should be there, and now I have access to htr step and htr index. Let me go to index, sorry, to insert again, because I'm looking for something. No, it's fine. Let me try it. Let me quickly try it and make main at name at city Amsterdam, get city, get name. Works. That's the first refactoring I wanted to do. And what else is duplicated? Let's see. What can be more, like, what can be cleaner, let's say. This one. When initializing the table, extend table, reset. Look, this is being repeated, no? But I think the more you make your functions generic and like move your logics into generic functions, the more spaghetti your code becomes. So I would keep the logic of my functions in a kind of linear approach. So if you just read it from top to bottom, you don't have to really go to the declaration of that function to see what is happening on there and then coming back and resuming your interpretation. So I would say for this one specifically, which I really want to insist that something is happening there with the memory by allocating zeroed memory slots to that entries, I would keep it like this. But in the second world probably Emad would just move it to another function as well and recall that. But I would keep it here. I think this is a very important part of this extending table function. So I would keep it here. So you can just read it top down. Then nope, I don't think we have anything to be actually. Insertion is there also. Yeah, works. I think it works. I probably also can just quickly create the deletion function, right? I can go with integer delete const character key, and there I'll go with the same approach, but this time, except returning the value, I'll go and mutate that. So here, let me check what is happening. I know where it is, if it is occupied, and there I'm going to return e value, which no, I'm not going to do that. I am going to say is state is empty, first of all, and is key is null, and is this is the part that is being repeated more, I think. Value should be null as well. So yeah, I like that part. I will go and do something like void reset entry. Oh, reset entry, and there I'm gonna get a pointer to the entry e, like that, and entries I. Yeah, I think I can just copy the one that I had here. Sorry, the one that is here, copy it, and put it here. And once I do that, reset entry, that's true. Here I think I can reuse that one, no? I can say like reset entry and simply do hd entries I would say. But what is the error? Telescope diagnostics. Call to undeclared function. That's good. I have to move this to before that line. Something like this. But here I get the pointer, and that should fix it, I would say. And probably I can also... Where's the delete? Yeah, it's here. Probably I can also simply say reset entry, and there I have the E. And E is a pointer actually, yeah. That should work. But here... No, that's fine, that's fine, that's fine. Yeah, I'm gonna reset it, and then... Should I do anything else there? Like freeing something? No. I need still that memory on the heap, but I just changed the state of it. So yeah, I'm gonna just keep it like that. And there I'm fine. Let's go to main.c and add a new one. I mean a new command, which is gonna be cmd delete. And let's add the mapping section here as well. So if it is delete, just return delete. That's true. And here I have to create a case in our switch saying if it is delete, character. Oh, I have to also add the hd.h. I have to add deletion to the header file to here. That's correct. I can use delete there. Are you okay? Are you kidding with me? I'll go with remove. And I can say remove maybe now. Okay. And here I have the key. Am I right? Yeah, I have the key. No, I can just directly use it, I would say. So delete or remove, sorry, the key, which is tokens 1, and then break. Yeah. Let me try this. You cannot. You're right. You're totally right. I shouldn't delete. No, there's no delete. I shouldn't return null anyways because it's integer. And I have to return 1. And if I cannot find any... Oh, sorry, I have to return 0 here because it means that I cannot find anything. And here I have to return 1 right after I remove it. Find and remove it, yeah. I think this should work now. And in our main.c, I have to also consider that section. Like, I have to say integer okay. If okay is not fine, I'll go with error, no key, no such a key. That should be fine. I can break it maybe also. No, I can just create an else and say printf successful or okay. That should be fine. Now let's make main print empty at name Emma at car BMW print. We have those. Delete name. Okay. I forgot the new line character. Now if I say print, the name is deleted. That's good. But I have to create this section of our code, which we put a new character, new line character. So in case I'm in for better kind of printing purposes. That's it. What we were trying to do, refactoring. Let's continue with our refactoring. Let's go to ht.c still. What are we trying to do here? ht size is init table size. That's fine. Reset. That's fine. I'm checking if the entries are still null, or that specific property is null. Then I return 0. That's fine. I think we can also improve the error handling of this program, because later on when we switch to core client or engine client approach, we have to really send back the error that what has happened exactly to your operation that you requested. But here we're just dealing with an interactive shell, and I don't think that's really important. So it's more putting on std out. But later maybe we can create something like a logger module, which could help us in terms of keeping track of the context of where the log is being happening. So, but I would skip it for now. I don't really see any other section I can improve. only the insertion. And what happens if I... Okay, this is a good one to check. Maybe. What happens if I run my program? Let me just rebuild it. And say @name emot. And when I print it, I see emot is there. And what happens now if I say atta, which is my brother's name? And if I do print, I have two keys. Damn it. Now if I say get name, I'll never get into atta, right? That's a bug also we have to fix. How can I fix that? So the behavior there, if you use a duplicated code, you have to duplicate key I'm in, you have to override it. And there I will go to insert and check if I can fix it quickly. So if it is occupied, I will continue. No, you shouldn't continue really. You should, if it is occupied, continue. But before that, I'll go like if e state is occupied, of course, and e key, or the key, equals e dot key, which means that it is occupied, but with the same key. I'll go with just replace the value. I'll go with that. How about that one? str duplicate. And once I do that, I want to just return 1, I would say. And I shouldn't really increase the count. I shouldn't increase the count by 1 because I'm just already using the existing occupied one. Should I free something there? I don't think so. So if I run the program again, let me recompile it. Oh shit. @name emot @name atta print. I still have the name and name there. What is the issue, you think? So let's go with, I always have an idea. So here, actually, let's just go through the code, right? We already have a key, which is stored like name, and the value is emot. And now for the second time, I don't care what is happening in the load factor. That's not really in the scope of this functionality. But then I go with probing, and there I see that it is occupied. Of course, the state is occupied, but the key is also the entry's key. Is that correct? Yeah. And then I set the value of that entry. This should really work, no? This should really work. Let me see if I really get into that point here. Make main @name emot @name atta. We don't get to that point. How come? I'm looking for insert, which is here. How come I don't get to that point? Let me print. That is occupied. That should be occupied, right? Let me print the is state first of all. I can't do that, right? Can I? And also the key should be same. This is an error or a warning. I'm not sure if it is going to break the compile, but let me just try it for now. I'll go with the key is this and the E key is this. So key and E key. And let's go with D here because that's an enumeration and then that's gonna have a value of a integer. Let's see what happens. Make re main at name emod 0 the key is name and the E key is null, exactly, so because we can just, so that's not true, right? That expression and that condition if statement I'm in, that's not true, so that's where we don't get into the block of it. And now if I say add name eta, it's gonna be like 1 true, the key is name and the E key is, should I break and return something? No. The second time, why it is running it 2 times? Look, the first, let me open the code here. Take a look at the insert function. Look, here it is, the point. So the state is 1 at some point, and 1 equals occupied, which is 1, right? Exactly. And then the key and E key is also weird. It is name, and they are completely same. But I would go with strcmp here. Also, I'm not sure if that can be the issue. Is key equals 0. I'm not sure if that's the issue. Let me keep this open for now because it's really hard to find the code again, and use another terminal tab like this and make re. There we have a problem, of course. We have a problem, we always have a problem. And we just changed it to D, as I remember. I'm not sure what happened. So main at name emod at name eta. Now if I do print, that's correct. So that was the issue. It's not like JavaScript or like probably any other, not any other, but like JavaScript kind of projects or Python that you compare strings like that is straightforward. So you have to use built-in functionalities like str compare. We fixed that issue as well. So now we get the values overwritten maybe when the keys are same. That's good. And we did some refactorings here and there as well. And I think that's pretty much it for this session as well, because it's just almost 45 minutes we're talking. Let's do the testing part, the unit testing part in the next episode. I would say that's going to be a good one in terms of learning lots of stuff, because I've never done unit testing in C programming language. So yeah, let's meet each other in the next one. Thank you.